Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. In this season of the Analytics Engineering Podcast, I'm digging deep into the world of developer tools and databases. If you're listening to this podcast, you've almost definitely used Amazon S3. It and its blob storage siblings at Microsoft and Google form the foundation for nearly all data work in the cloud. In many ways, it was the innovations that happened inside of S3 that have unlocked all of the progress in cloud data over the last decade. But if you're anything like me, you have a pretty lossy mental map of what S3 actually is, of how it works its magic. In this episode, I set out to fix that. I talked to Andy Warfield, VP and Senior Principal Engineer at AWS, where he focuses primarily on storage. We start back a couple of decades ago, where I got a crash course on virtualization, hypervisors, and Zen. We then switch to AWS and go deep on S3, how it works and what it unlocks. We close out in talking about S3 table buckets, why they're important, and what they suggest about the outlines of the S3 product roadmap moving forward. It was a pleasure to speak to Andy, and I hope you enjoy it as much as I did. Without further ado, let's get into it. Andy Warfield, welcome to the Analytics Engineering Podcast. Great to have you.
Thanks for having me. It's super exciting to be here.
You've done a lot over the last 20 years.
Great.
There's a couple of areas that I want to get into with you specifically. But before we do that, can you just share a little bit about your journey as a software engineer?
I just like playing with computers. I'm Canadian. I did computer science in Ontario as an undergrad, and then I came out to Vancouver and did some grad school, and then I moved to the UK and did more grad school. And so, did my PhD in the UK. I worked on operating systems. I always really liked low level stuff. I worked on this super fun project in the UK that was a hypervisor called Zen. And it ended up being a thing that a lot of the cloud providers, including Amazon, used early on. And then I wound up doing a couple of startups. We did one on Zen. Then I decided to be a professor for a little bit and worked as a professor in Vancouver at UBC and taught operating systems and networking and security stuff. And then I did another startup that was a storage startup, and then I wound up at Amazon. And so I've worked in I have this like highfalutin role at Amazon where I'm a VP and an engineer. And I've worked across initially S3 and then all of the other storage services, and now across a bunch of the analytics services. So I get to cause trouble in all sorts of areas of the cloud.
A VP/distinguished engineer, does that mean you just get to march around and tell everyone why their stuff is bad and why they need to do it better?
People love it when I do that. That's totally the thing. I think probably half of the time, this is probably not a very precise allocation, but like half of the time, I'm probably causing trouble by trying to start things up and get folks to do neat stuff. And half the time I'm patching up the mess that I've created in that first half of the time and trying to help teams, just dig out from stuff when they're trying to figure things out and stuff. So I kind of get to cover the whole gamut of stuff.
But you don't have, in that role, you don't have direct reports. Is that fair to say?
I do.
Okay.
That's a good question. So I think most folks in my role don't.
Okay.
Just through running engineering teams and startups and being a prof, I've always kind of had a team of some size, not usually like a massive organization. So I do have some direct reports. The direct reports that I've had at Amazon kind of fall into two categories. We have applied scientists. A lot of them are like faculty visiting from universities. And so when faculty come and visit, I have a bunch of those folks that work for me. Sometimes they decide to stay. They do all sorts of crazy, fun stuff. And then occasionally when there's a team that we're trying to do something, really interesting and innovative with, I'll take over running that team for a year or so. And then just try and spend more time. And that I think that's more for me than for the team, right? Like it's an opportunity for me to dig in and do stuff with real engineers.
That seems like a pretty good gig if you can get it.
It's amazing.
You've been there for what, 7 years or something?
Yeah, about almost 8 years, I think, and
Okay.
I love this job. It's actually like really fun.
I want to talk about Zen as the kind of first meaty topic, but you said I was always interested in operating systems. I think that's a statement that was like that's like where you were at in your career and interests in the like early 2000s. Is that fair?
Yeah, that's probably. I mean, geez, this is like a dating thing. I was doing undergrad and grad school from the like second half of the '90s through the early 2000s.
And, I'm well, obviously way farther away from this than you are slash were, but I would not have anticipated that the thing to be fascinated by in that time period would be operating systems. Like, this is the era when Linux is starting to take over the server market and Windows is totally dominating desktop operating systems. What was the thing that drew you to that part of the world?
When I was a kid, I don't know, we didn't have a ton of money. I like cobbled together like computers from garage sale parts, like literally garage sale parts. In Ottawa, where I grew up through high school, the federal government, it's the capital of Canada, so the federal government's there, and they have this department. I think it's called the Department of Supply and Service. This is like a super weird story to tell you. That had this like massive warehouse that sold off like retired government equipment. And so I started this business in high school where I was like going in and bidding on these
Huh.
lots of old, like you would buy literally like 8 pallets of stuff and you would buy it for like $200. Like it was, please
And
take
who
your.
even knows what's in those
Right. Well,
pallets?
you like go in, you could like look around, but you couldn't really tell. And then I would like put stuff together and then kind of resell it. It was like kind of like like an early, I guess, business thing. And so
It
I
seems like a good margin business. You've got a good source of
Yeah, so there's a
supply.
lot of like, classified ads and stuff like that. I learned a ton. And some of the things that I ended up building and selling were like, even then, like generation old machines. I remember getting this like massive lot of IBM display writers, which are these like old, they only did word processing and they didn't just have floppy disks. They had like 8-inch floppy disks. Like they made awesome frisbees. They're like massive. The disk drives that you put these 8-inch things into weighed like literally like 75 pounds, and they had these epic printers. The printers were like these letter quality, like I can't remember what they're called. They're not daisy wheel. They're the head, like the metal. They had a metal head
Oh,
that looked like a golf ball that had all the
yeah,
letters,
yeah, yeah.
and the printers were so loud that they had their own like 3/4 inch plywood enclosures because they sounded like people were like testing machine guns in your house. But they produced beautiful. They were like typewriters basically. They produced like at the time like beautifully printed things, and I like fixed them up and sold them to people that wanted like like a WordPress. It was the '90s.
In the process, you had to put something on them.
Yeah, and so I had to go like figure out the software for them, and that kind of got me into old machines. I played. My dad was a chemist and worked in an office that had an old VAX PDP-11, and so like I'd go in and play games on the mainframe and stuff like that. Like I just kind of loved like understanding how all that stuff worked. And I guess it led into me like working with Linux when Linux was reasonably early on and doing a lot of like hacking around with the Linux kernel and then ending up, doing a bunch of stuff in like operating systems and networking in grad school.
Okay, so that's a good lead into Zen. I did a little bit of research ahead of this. I'm interested in virtualization because, while technically it's solving a very different problem than DBT solves, logically there are some similarities between the virtualization trend that happened in the 2000s and what DBT tries to do with the data warehouse data lake. And I'm always curious about it because I have all these questions about how do you solve the technical problems? How do you solve the kind of business model challenges? How does the kind of ecosystem respond? Because, some people might like to see that. Some people might not like to see that type of thing happen. But if we just start out from a place of like, what the hell is a hypervisor? Why did the 2000s, like, why was this such a big topic in that time period?
So there's two answers I think to this question, and it's like hard to like rewind and like remember what things were like then, but I think in the 2000s we were starting to see like a lot of growth of server rooms, right? And in a lot of cases, very practically, for businesses, um, a lot of especially enterprise applications, the OSs at the time weren't super good at like isolation in the face of like big enterprise applications, right? And it wasn't so much the performance isolation as it was, I mean, there was that factor, but also like config isolation, right? Like, like a beefy application on Windows or Linux would go and do all sorts of stuff you know, in like the system registry or inside, like Etsy. It would tune the system for itself, and things would step on each other's toes. And so as a result, for that reason, and for just the simple reason of like administrative isolation, like having one person that had root on a machine, um, folks tended to buy like single, those old pizza box 1U servers, right? You'd go into the server room and see a rack of pizza boxes in there, and those pizza boxes were idle all the time. And so there was like this sort of like hope that there you could like really steal an opportunity to get a pile of utilization improvement if you could run virtually a bunch of those machines on the same physical hardware. So that's kind of like the businessy pitch. It made for good like introductions on papers and stuff too. I think the other bit of it was the x86 in particular, like the Intel CPUs at the time fell into this category that was like the CPU was. There's actually like old research papers that kind of categorize whether a CPU is virtualizable, and the x86 was not. Right, there were a bunch of instructions that behaved differently depending on whether you ran them in like kernel mode versus user mode, and they wouldn't like trap in user mode in a way that let you run the kernel. And so there was this big like stunt component to the thing where like I think the group of us that were working on the thing were like, can this even be done? Right? Like,
Huh.
and can it be done in a way that's efficient enough to like legitimately use it?
So I was reading about this. This is like VTX, is that right?
It led to a lot of the Intel VT stuff and like the other CPU vendors. Like it wasn't just us. Like there were a few other projects looking at virtualizing the Intel CPU, but a lot of what came out of that body of research was the CPU vendors changed to really embrace and help get performance for virtualization.
You would have, well, I don't know. I would have thought that a company like Intel would actually be pretty resistant to a change like this because you might be able to get away with purchasing fewer chips if, in fact, you can utilize the chips better, create more workloads onto them. But in fact, they actually participate in this trend by like releasing this like enabling technology.
Uh-huh.
Why did it make sense for them?
I've had that same thought about like not just Intel, but like all sorts of places that I've worked in terms of my technology career, where like you kind of go like, oh well, by not doing this work, you would protect market share or whatever. I've
Hmm.
never seen that play out well, right? Like it 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 is always, I think, the thing that enables people to move faster and do more that kind of leads to more use. And I think Intel was totally right, and in the push that they did there, like really created this abstraction that was super powerful.
But before this era, there had been hypervisors. They were just like bad and slow, right? Like there wasn't this
Oh no,
like
there were hypervisors that were like awesome. They were just on machines that were like the size of trucks, right? Like so the
ah.
like the old it is like one of the weirdest bits of like computer science research. There was a ton of hypervisor work and virtualization work on the old IBM like 360 mainframes. Right. So like in the 60s and 70s, they were like actually like super insightful, like like in a lot of research areas, the early papers aren't burdened with all the stuff that comes after, and they're actually like really clear in how they talk about stuff. The virtualization papers from the like like the 70s are fantastic. They're like really really, and but then everybody just stopped. Like the like PCs came out for like years and years, nothing really happened. There were a couple of like I think like early x86 virtualization packages. I think there's a thing called DeskView or something like that, but like nothing really meaningful until the beginning of some of the Zen stuff and VMware in the cloud.
That's fascinating because you were saying before about how you could split up the hardware resources and give everybody their own root access. You could imagine kind of responding to that in one of two ways. One is like take the larger machine and divide it up, or the other one is like make the machine smaller. And it seems like the first iteration of this was actually like the IBM mainframe, and actually the first response was make the machine smaller. Like
Yeah,
the PC
yeah,
was a
yeah,
meaningfully smaller machine, and then later we did the divide the machines up approach.
yeah.
Okay, so there was Zen, there was VMware. Were those the two kind of big players in this space?
Oh dear. I think that like in my memory, I feel whenever I have like get to have conversations where we talk about these like history moments. I like later in the afternoon, I'm going to go like, oh shoot, I totally forgot about this really obvious and important thing. Those are the two that stand out in my mind that we spent a
Yeah.
lot of time with those two.
And the way that it seemed to work out then is that the other players in the space, whether it was the PC manufacturers, the server manufacturers, the chip like everybody saw this same future and everybody marched toward it together, or were there forces in the industry that were saying like, no, we don't want this?
No, it was. I mean, I don't know how much gore you want to get into on this, but this area is like it's kind of fascinating. So, like the Zen and VMware stuff did fundamentally different things technically.
Oh, okay.
The early Zen code actually, like, we shipped our own version of Linux initially that changed the instructions that Linux used to make it virtualizable,
Huh.
and then like worked with Windows, like with Microsoft researchers to do the same thing to Microsoft. And then only later, as we got hardware support from Intel and so on, did we like shift to work with unmodified OSs. Whereas VMware did this like remarkable thing where they did dynamic binary translation. Like they actually ran a little thing that took the instruction stream that the CPU was going to run and they rewrote it to like patch it live, which is insanely complicated code to keep right. And, like that team, they're like nuclear physicists. Like they're like some of the smartest folks in the industry that were doing that. And it was like a constant chase to stay on top of like all the edges. So those two things kind of like,
Because the chipset underneath of you is like changing, and you have to change the way that you're translating. It's
yeah, and there's always application instruction set patterns that you haven't seen, and there's like all these weird side effects, and there's like, especially once you get into like multi-core stuff, there's like non-determinism, and like it's crazy. Like there's some really complicated technical stuff in there. But on the Zen side, to your other question, there were a lot of folks that were super interested in Zen. Ended up, I think, being like this open source Switzerland of this stuff, where like we had all of a sudden all of these like industrial folks like HP and IBM and so on, like really piling in to contribute. So we went from being a bunch of researchers to finding ourselves like mediating a whole bunch of like open source stuff to then having some of the cloud providers taking the code and starting early cloud businesses. It was a really like educational time.
so a big chunk of Zen was open source.
Oh yeah, the whole thing was, we did the
The
whole
whole
thing.
thing.
Yeah. And then we did a startup off of it afterwards that was an enterprise software company, but it was really like building like an enterprise wrapper for the open source hypervisor.
Got it. Okay. Maybe to do the transition, how did this get picked up by AWS and when? And was this like all the way back at the founding of AWS? Like there was like a hypervisor that needed to be selected, and yeah, tell me the story there.
I was not in any of the AWS conversations that led to that. I think, and this is a history that we should get like some like super tenured AWS person to like weigh in on. But I think what happened was there was this awesome startup, and I may get history totally wrong here, but I think the startup was actually called Elastic Compute Cloud, like the EC2 thing, out of Cape Town, South Africa. And AWS was like working on their own, well, Amazon was working on their own cloud, and starting to like run a lot of the retail operation on their own data centers, and they ended up like seeing an opportunity here, and they ended up picking up that startup of these like South African guys and like building from there.
And those folks then would
And
have
they were using
they
Zen,
made the decision.
and they were
Yeah, okay.
building like a sort of cloud control plane for Zen.
That's wild. The history of technology always involves a dose of happenstance.
It totally does. Well, and like we were wrong like crazy on that thing, right? Like the team of us that did the open source Zen work were like, this cloud thing's never going to go anywhere. We'll build a enterprise software shrink wrap product around it, and kind of called the wrong side of that one.
I mean, it is probably, you couldn't really imagine the cloud existing without this technology, right?
Yeah, which is to say that like someone was going to build it, right? Like
Sure.
it's like the happenstance thing.
Okay, let's keep going with the AWS story. And I understand that you weren't there for this part of it, but maybe you can do it a little bit of narration. I think S3 and EC2 were the first two services. Is that right, or did EC2 come first?
Oh, you're asking me all the questions that I like feel 90% confident I can answer properly. So like I think S3 was first, and
S3 was first. Okay.
S3 was first, and I believe SQS may have launched before EC2, but I should go and like
Oh,
get the
fascinating. I did not know that.
actual scoop on this. Yeah. But they're like very, very close together, those launches. But S3 likes to remind everyone that S3 was first.
Okay. I have an SSD on my MacBook, and I have built computers before. It's been a while, but I've built computers before that have SSDs in them. I like kind of vaguely understand how an SSD works, how it like reads and writes, blah blah blah. And I think a common misconception is that S3 is really just like a bunch of SSDs all stuck in a data center somewhere. I'm sure that like on some level there are like actual physical drives involved, but it's probably a lot more than that. But the like conceptual abstraction is pretty lossy. How do you explain what the hell S3 is? What is involved in making this thing?
That's my favorite question you've asked so far. I guess it kind of depends who I'm talking to. If I'm talking to somebody that's not into the super technical answer on this, the way that I find myself often talking about it is that when S3 was created, it was a lot like the storage locker facility that you go put like old tools and furniture you don't need but can't bring yourself to sell across town. And you would like go rent a truck, or you would put it in the trunk of your car and you would drive across town and you'd jam the stuff in there and you would know absolutely that it was safe because it was like big fences and like really good like fire protection and stuff like that.
But like the latency
It
characteristics
was
were
a bit of
not
a
that
pain to
great.
get stuff there, right? Like it was kind of hard. But that was like in the early days of S3, like the early S3 PR FAC was really around like a file system for the internet, right? But it was really a lot of people were putting backups into it. A
Mm-hmm.
lot of people were ultimately using it as like an origin for CDN based media and stuff like that. Like where it needed performance, it was protected by a CDN, or things like that. People would run websites, which in turn lent themselves to CDNs over the websites and stuff. Um, I think the thing that happened next, we can switch gears and talk about the hard disk part as well. But like to play this one a little bit forward really quickly, I think the thing that happened next was Hadoop took off, right? The MapReduce workloads on top of like private HDFS clusters, and that community wrote S3A as an adapter to make Hadoop talk
Yep.
to S3 instead of HDFS directly. And it turned out that S3 had enough hard drives that like you could drive a lot of parallel bandwidth, and it was like an efficiency of scale in the cloud there. And the rest of the S3 story is variations on that theme, right? Like customers have been more and more demanding with how they work with data. They've needed like lower latency, like richer semantics on consistency and stuff like that. And that's kind of like the walk forward on things. To go back to the thing you were saying about the SSDs, I mean, it's mostly hard drives. Um, and it is a lot of hard drives. The like super fun stat on this that I like sat down with the team and we worked this out a few years ago. So I've mentioned this in a couple of talks. Is um, oh, I'm going to screw up the exact numbers. I think we looked at the like largest customer footprints on S3, and I believe that we found, and I can get back to you with the real number for this in case we have to correct it, but I think we found that there are the thousands of largest S3 customers actually have a bucket that spreads its data like individually, right? Like these like large footprint customers have their data spread over millions of physical hard drives, which is like a hard thing to wrap your head around. The idea of like, yeah, I've built a lot of like physical storage systems in the past. I've built like RAID arrays and like scalable storage and stuff like that. The idea of packing, if you think about a 3.5-inch hard disk, right? It's like, a few times the size of your phone. And you imagine like a million of those. That's what like some of our largest customers have in terms of storing their data.
So it's not crazy to imagine that there are like actually a billion hard drives involved in S3 across the world.
There's a lot of hard drives. We don't talk about any of those numbers,
Yeah.
but like
Yeah.
there's loads. And I mean, when I say those customers have their stuff across a million hard drives, the thing that's important to remember is a lot of other customers share those million hard drives, right? And it really literally is this thing of hard drives are like terrible in terms of performance. Like they're awful pieces of media from a performance perspective, but storage workloads are so bursty that like co-locating and spreading like data really really wide lets you burst into a ton of capacity and then be cold the rest of the time.
Okay, so that's a good callback. I didn't ask you about, I think that's the specific thing that you did associated with Zen was storage virtualization. We talked mostly about like virtualization of the operating system and why that makes sense from a CPU utilization. But storage virtualization, I get the sense, is useful because of what you just said, the access patterns. And if you spread your data across more disks, then you can actually parallelize it really, really nicely. Am I right on this?
Yeah, the bit of Zen that I spent the most time working on was the IO path. So I did a lot of stuff with, like, virtualizing file systems and virtualizing the block IO path and networking and stuff like that. But yeah, I mean, the immediate problem we created when we virtualized the, like, Linux computer on one computer was there was still only one hard disk underneath it. We didn't have SSDs at the time, and so now you had to figure out how to virtualize the address space of the hard disk. And so that was a bunch of what I worked on early on.
And so is it whereas on my local machine, if I have, whatever, a 12 core processor or something, and it's all using the same SSD, that mapping kind of totally breaks down in the cloud. It is actually kind of indeterminate how many physical drives is it possible that, like, let's say, okay, I've got a table and it has a bunch of Parquet files on some level that are making up the contents of this table. Is one given Parquet file even going to be guaranteed to live on one drive, or does that even get sharded across many drives?
No, we shard it for a bunch of reasons, right? We shard it to meet the durability requirements of S3, so we add redundancy in there, and to spread it across AZs because we engineer to be able to lose the facility in S3. So no, the Parquet file, especially as they get larger, spread broadly across a bunch of hard drives.
That's fascinating. One of the things that is required in order to make any of this work is that, again, if you go back to my MacBook, all of this is connected through pretty high speed interfaces to my through my motherboard. In the era that you were talking about, kind of the early days of S3, where ingress egress is slower, my guess is that the biggest limiting factor was network. I mean, network in the early days of the cloud was, I think, generally a bottleneck.
I think that's an insightful observation for sure. I think that a lot of, I mean, like S3 in particular has, like, evolved with its customers for years now, and I think in the early days, um, it certainly didn't perform the way that it performs today, but it certainly also didn't have the demands in terms of throughput on it. I remember in my early days as a prof at UBC, we were doing a storage project, and it was like my first time playing with S3 as a researcher, and we, like, wrote a bunch of code that was trying to store a whole bunch of stuff in parallel to S3, and we got a phone call from the S3 team going, like, "What the heck are you guys doing?" Like, it was just like the customer experience back then was, I don't think that there were a ton of folks, this is ages ago, like, driving that kind of load. Whereas today, um, especially with the analytics workloads being written to, like, draw parallel bandwidth off of S3, we see customers driving hundreds of terabits a second for individual workloads into.
You mentioned SLAs. I think that it might be the most famous thing about S3 is the, like, almost comical number of nines that you support. Can you talk a little bit about what the SLAs are that you folks provide, and what does it even look like to operate in the type of environment where you are providing that type of guarantee?
I won't do this justice, and so there's, like, a couple of great talks on this. Well, there's a great one that Seth Markle and James Bornholt did at reInvent last year that's totally worth watching. They go into a lot of details about how erasure coding and stuff works inside S3. There's a separate fun talk that Seth and I did years ago about how we think about durability on the team. So those are, like, for folks that are really interested in it, those are two resources that go a lot deeper. The 11 nines thing, I mean, it's a very interesting thing. I mean, it's a design guideline.
11 nines is your data is always available, or your data won't vanish from the internet?
Well, I mean, we use it actually in a really precise way as engineers, where we use it to model uniform random failure of components, right? Like drives and servers.
Hmm.
And under, like, our experienced annualized failure rate, like, we make sure that we have enough redundancy to keep data safe with a wide margin,
Hmm.
given those failures. And so if you think about it, you kind of got this, like, control system where you've got, like, a bunch of erasure encoded copies of the data, right? Like, so I don't know if that is a term that will, like, resonate with your audience. So, like, if you do RAID or whatever, the most simple way to keep backups or extra copies of a data is to literally copy it a bunch of times. right? But then you pay the whole overhead of each copy. And you just put them on different disks, and if a disk dies, you're fine. And there's a bunch of math in coding theory, like erasure coding being the most common thing in storage, I think, for them, where you can store less than a full extra copy of the data. So you take the first copy, you slice it up a bunch, and then you calculate a bunch of parity shards like you would on a RAID array. And typically it's a k of n code. There's different, like, people are like super all over the place with how they use k and n, but if I have 7 of 10, right? I can read any 7 of the resulting 10 identity and parity shards. And so I can place those 10 shards wherever I want. And as long as I can see 7 of them, it's fine. And if I lose one, I still have 2 more before I run into trouble, and I can go and rebuild the missing one, right? And so when you think about, I think most cloud storage systems, you're dealing with this like buffer of redundancy, and we are constantly monitoring the failures that we see, and we have a fleet that repairs. And so we're like designing redundancy to be well ahead of any conceivable failure that we might see in the fleet, and then we're like always charging ahead to repair any failures that we do see as things go, because hard drives fail eventually, right? And some hard drives fail when they're young, and so you just like in the cloud, failure is just like part of the physics of the infrastructure. And so S3 just builds to maintain this very high level of durability above that.
You must have that like unbelievable predictiveness in terms of the actual failure rate of these different components. I have to imagine that you've got depreciation schedules and failure schedule and all of this stuff, but it's well under 10 years, right? Like these things are not living for 10 years.
We're really sophisticated in terms of failure, right? And
Yeah.
we look at every conceivable. This has been a thing that even over the time that I've been here, the amount of depth that we've gotten into understanding the ways that hardware and software fails, and how we can like insulate and move fast. It's like it is very much like a logistics style system,
Yeah.
and a lot of the
Which
things.
Amazon's very comfortable with.
Totally. And we have a scale that allows us to have a lot of predictive strength over things. And so it is like a wonderful like machine to work with on this side. It's really, really cool.
So you were talking before about the different use cases for storage, and websites being early, and there's CDNs on top of that, which kind of fixes the ingress egress, whatever, the responsiveness problem. And then Hadoop came and analytics, and it seems like that workload, ML AI analytics, is the thing that is primarily pulling the machine forwards today. Is that fair to say? Like that, there was probably an era where like video streaming on demand was like your number one growth vector, but it sounds like the volume is mostly in the analytics world.
That intuition, I don't even know if it's the volume, but it's definitely, we're super responsive to sharp edges and to like places where we can see it. I think that I love about working on at Amazon all up, but on the storage teams and S3 in particular is we like really spend a lot of time talking to customers. And like when things go wrong, right? When somebody's struggling, I end up on like a call with them, and we're like talking about what their code's doing. Like I certainly have never had like such a frequent and diverse opportunity to in a like business work directly on like real technical problems all the time, and like that shapes our roadmap like crazy. And so like you say, like whatever, like 5 or 6 years ago, a lot of those calls were around like media streaming and things like that. That was certainly an area where it was like emerging, and we were like tackling, and on that one, like tail latency is an example of a thing that we engineer around, and some of that results in like internal focus, right? So like you're making like on streaming, right? You're always sensitive to like the slowest requests, right? Those are the things that are going to pause rendered frames. And so when you're dealing with like thousands or millions of hard drives, right, you've got like there's always a machine that's failing. There's always an opportunity for something to go slow. And so internally, we focus a ton on tail latency and making sure that the slowest request is not that much slower than the average request. But there's also a bunch that you can do on that on the client side by like being impatient, for example, right? If a request is taking too long, right, we encourage you to go and re-request to like give the system another chance, because you might be hitting a front end host that's having a bad day, right, or something like that. And so at the time there was a lot of that. Now, like you say, I would say it's a ton of AI/ML and analytics. The other thing that we're seeing a lot of is sort of emerging like startups and like there's a lot of reinvention happening in like infrastructure software. And so whether it's like observability, databases, there's so much happening in databases right now of folks building directly on top of S3 and storage and stuff. And so in all three of those categories, there's a lot happening, and that's definitely pulling a lot of what we're doing.
God, I could spend so much time on this intermediate part of the story. But the thing that I want to make sure that we have time to get to is S3 table buckets. It's not entirely surprising, given that what you were just talking about, that you folks have gone so deep on Iceberg, on open table formats. I feel like this is the first. I mean, I don't follow the S3 release feed as closely as maybe I should, but I feel like this is the most use case specific functionality that you folks have shipped before. It's like very clearly for AI and ML. It's. Can you talk about the feature and what made everyone internally excited about this direction?
So S3 did years ago launch BitTorrent support. So
Okay, fair.
there is that. But
Yeah.
S3 serves an absolute ton of Parquet. And so, like, even leading into this, the aggregate Parquet request rate, I'm so terrible at remembering like numbers for these things. I'm not even going to invent it, but it like there's a lot of Parquet served out of S3. It's a dominant data type, and it's just a dominant data type. And so I spend already a ton of time working with customers, building data lakes, working with Parquet, doing Parquet performance and scale stuff, working with Hadoop and Spark and so on. The thing that we really saw over the past 3 or 4 years was OTFs really picking up, and especially our largest analytics customers, like moving into OTFs, especially Iceberg, and telling us like we want a table abstraction. Like they were pretty pretty clear about it, and the experience that folks were getting. So like Parquet is a structured table format, and it could be stored as an object on S3. And so you would get folks either like dumping logs or storing data sets in Parquet, right? I'm sure you're like familiar with the like, just load it into pandas and run at it. There were sort of improvements to that structure with things like the Hive Metastore, where people would stand up Hive and be able to append in and partition and scale load on top of stuff. But still, the place where we were really seeing people pulling was they wanted a first class table abstraction, right? They wanted upserts and like the ability to do mutations in the middle of tables arbitrarily, and they wanted schema evolution, all the stuff that Iceberg like was motivated by, right? In a lot of senses, all of these Iceberg Hootie Delta formats are kind of like they're kind of like a list of sharp edges with Python with Parquet on S3, um, and so the thing that we were seeing from these like early customers building at scale with Iceberg was operationally it was a bit of a struggle for them, right? Like it was great at the beginning and it was like opening up a bunch of stuff, but the way Iceberg in particular does writes produces tons and tons of Parquet files. And so performance would fall off and then they'd have to run their own compactor, and like operationally running the compactor was a bunch of work. Or they would build their own compactor catalog and they would like run into bugs that resulted in like lost references and stuff. And so the conversations were really like, this stuff is super cool, but can't you just make it a whole lot easier for us to run? And I think the thing that is like maybe a standout difference in terms of how I see certainly myself and the team thinking about it relative to a lot of the analytics folks that initially worked on Iceberg is um, we're approaching it as a storage primitive to support analytics rather than the bottom end of an analytics stack, if that makes sense. Right. And so like if I talk to somebody that is like a super deep engineer working on Spark or whatever, right? Like they're excited about Iceberg as a table backend for Spark, but in their head, I think in a lot of senses, they're almost thinking of the whole thing as a database engine. Right. And they're kind of thinking of that whole thing turning into like you will run that Spark instance on top of Iceberg and it will be the only thing. And for us, we totally want to support that use case and have it be awesome. But we also want you to be able to come along with PyIceberg and do a command line insert into the table because that's how we see people work with objects. And we totally want you to be able to come along with DuckDB in an app on your phone and work with it end to end end. And so we're still kind of like, I think, evolving the abstraction, but we really want to get to a point where this is like a super universal table abstraction that you can bring anything to.
So let me make sure I understand what exactly is involved here, because there's certainly, when it comes to Iceberg, there is the format itself. You need to actually be able to read and write the files. Then there is the catalog, which manages the acidity. And that catalog is not, I mean, it does require files that are stored somewhere, but it is also like a service that has to actually like be stateful, I think.
Yeah, Iceberg has moved to this REST catalog for sure. So there, yeah.
And so are you folks, is a part of S3 Table Buckets hosting a RESTful catalog?
Yes, part of the API to S3 Table Buckets is a Iceberg REST catalog, an IRC endpoint. And that's when we first launched, Iceberg was in the middle of transitioning from like the older Iceberg connectors to the IRC. And so when we first launched, when we talked to customers, the IRC wasn't there, and they were like, just do the thing that everybody else does, ship a jar to connect to S3. And so we did that, and we immediately had customers go like, why aren't you supporting the IRC? Because the IRC had moved in that year that we
Sure.
were developing.
It's moving very fast. Yeah.
It's so fast. And the thing that we immediately found was we really want to support all those like command line tools and other clients. And if you have to ship this like jar with the thing that tells you specifically how to talk to S3, we're gonna be hamstrung on every feature we every launch, right, and stuff around having to ship that software. And so we immediately, it was all hands on deck after the December reInvent launch. We launched the IRC support in March.
Got it.
So
So it's a fast follow. And
yeah,
the initial launch of Iceberg Table Buckets was just this past reInvent.
yes,
And so then there's compaction,
yep.
which I think is more like an agent type thing. That's like a process running in the background. Is that fair?
Yeah, I mean, it's like a table maintenance kind of app. So it goes and it reclaims stuff that you've deleted because everything is copy on write, and it goes and like sorts and cleans up stuff. It regains performance. It turns small Parquet files into big Parquet files.
And while I totally get what you're saying, like I want to make Iceberg as a backend kind of just available as an infrastructure primitive. These two elements, the Iceberg REST catalog and the compaction agent or whatever you would want to call it, these are like new things for S3, right? Like if I'm operating a video on demand service, it's not like you're going to like unshard all my files. Like you're not going to like do a bunch of stuff on my behalf. My application has to implement that logic itself. Fair?
Totally fair, but I think we think about it a slightly different way, which is that the thing we were talking about earlier with like hard drive AFR, right?
Hmm.
We are already
Yeah,
running
that's
massive
interesting.
fleets that are like making sure that we've got all of the shards of a given object, right? And it's like complicated at scale, durability sensitive work. And we're kind of going, objects are super important, right? There are all these Parquet workloads. Like clearly there's this like structured data abstraction. And S3 has always been about like data APIs for developers, right? That maybe we need to weigh in a little bit more on the semantics of a table.
Yes. Okay. That's exactly what I wanted to hear you say. I think that's neat. Okay. From that jumping off point, what does the future of open data look like? Like, you talked about the Spark developer. If that's the world that people are in today, like, where do you want people to be in 5 years?
What's the law? There's like a super fun law where people think everything moves really slowly in the moment, and they are shocked at how fast it moves in retrospect. I kind of feel like that at this point about the stuff that like S3's done over the past bunch of years. Like nothing is ever going fast enough. I'm always like frustrated that we're not getting more stuff done. But then I look at like some of the stuff that's happened. It's been pretty neat. I think that the team has really like matured into this view of like really looking at S3 as a collection of data APIs, right? That like if you're sitting down to write an application to do anything with data, right, at any level of performance, at any level of durability, like we should remove any friction between you and the data you want to work with, right? You shouldn't ever think about storage, right? The moment you're thinking about storage, we're like not doing our job, right? And some of this like tables work has really been to carve away those layers of like work, honestly, between like Parquet and scalable Parquet and being able to mutate tables and like Python and Pandas or Daft or whatever the tooling that you want to use to get at that data is. Um, I kind of think that we will continue to do that on a bunch of other fronts, right? Like one of the reinvent, you mentioned the AI/ML space. A thing that's like remarkable in that space was over the past, I don't know what, like 4 years of Gen AI stuff taking off. Some of the largest models have been trained on AWS and on S3. And so when you're looking at like massive scale model training, the training data is on us. But at least for the early round models, the LLMs, like the total amount of text to train an LLM in the scheme of storage is not that much, right? Like as we're moving into multimodal, like video and images are much bigger sets, but those models checkpoint their state all the time as they're running. And so checkpointing workloads were super interesting for storage. But the thing that we're seeing this year is like, maybe it's like the past, like few years, but like, especially like now, inference is really starting to kick in at huge scale with some applications. And applications that are doing massive inference, are like, like loads and loads of times a second, needing to go and do a vector lookup and go and find relevant data, right? Often out of like document collections in S3 or image collections or things like that. And that RAG, like the retrieval augmented generation workload that needs to go and find context, right? And relevant data for a prompt, is a thing that kind of depends on building the appropriate metadata. And so at alongside S3 tables, we launched for S3 this metadata feature that uses S3 tables to allow you to build descriptive metadata about your objects. And that's a thing where if I go look at any of the large foundation model training companies or any of the customers that are building like inference heavy applications, they've all gone and invested in their own sort of data augmentation layers. And they're all like, oh, I do all this work, but then my metadata is kind of stranded because it's in my like table format or whatever. And so by kind of like schematizing that and building that into a sort of semantic layer on top of S3, that's another place where we think it turns on semantic search over S3 and stuff like that. So there's another example of building on top of tables and addressing like another bit of like API gap that we were seeing builders have.
That's fascinating. I love that. You obviously follow Iceberg super closely. Is S3 table buckets specifically tied to Iceberg, or is it flexible in terms of the table format you're using? One. And two, based on your read today, is Iceberg ready to be deployed at enterprise scale? Or is it purely the purview of digital native, highly technical companies, or is the enterprise ready for it?
So on one, we leaned into Iceberg because it was the customer voice on stuff. We didn't call it S3 Iceberg because, we weren't sure how any of that stuff was going to go. And really, we wanted a table abstraction. And so I think we're kind of in a let's get this right on this one platform. And like a lot of what we're building, like compaction, we could ultimately make work on other formats. Although I think there's a lot of trend. If you go listen to like Ryan Blue's kickoff at the Iceberg Summit a few weeks ago, right? There's a lot of like, I think
the gravity is pushing the industry in that direction. Yeah.
The readiness, I mean, we've got some pretty sizable customers moving on to Iceberg at this point. I think as with anything, Iceberg, the format is in great shape. They're about to launch V3 of it, and it's moving quickly. I think that we've got to a great operational position on it with S3 tables. I think that there are still like things that Iceberg will grow to get better at, right? Like lots and lots of small updates directly into Iceberg is not a like great recipe for performance on Iceberg, right? You need compaction to come in and clean that stuff up. And so I would say for anybody, and this is hardly true of just Iceberg, but like for anybody, I would kick the tires and like go and figure out if it performs for the application that you have. But we're definitely seeing Lakehouse customers, right, moving and starting to build at pretty impressive scale on top of tables.
I feel like I've got to let you go because if I ask you one more question, then it's going to just be an entree into like a whole nother hour, and you're going to start asking me to buy you beers at that point. But this was tremendously fun. I feel like I have a mental map of S3 in my head that I did not have
Cool.
at the beginning of this conversation. So thank you for that.
Awesome. Well, thanks for taking the time to chat. It was super fun.
All right. I'll talk to you soon. The Analytics Engineering Podcast is sponsored by DBT Labs. I'm your host, Tristan Handy. Email us at podcast@dbtlabs.com with comments and guest suggestions. Our producers are Jeff Fox and Dan Poppy. If you enjoyed the show, drop us a review or share with a friend. Thanks for listening.